Welcome back to the Deep Dive. This is where we take compelling sources, tear them apart, and distill them down to the crucial insights you need. Our whole mission is to save you hours of reading while making you genuinely well-informed.
And today's deep dive is laser focused on a really powerful piece of analysis in global urban planning. We are drawing exclusively from Chapter 14, titled Sustainability and Inclusivity.
Right. And that's from the foundational text, Smart Cities, China's Model of Success by Eduardo Moreno L.
Exactly.
This chapter, it's basically mandatory reading if you want to understand how you can possibly reconcile massive scale modernization with, global environmental goals.
It really is. Moreno lays out precisely how China's smart city model is trying to tackle two monumental interlinked challenges.
And those are
Reversing environmental degradation on one hand, and achieving the UN's Sustainable Development Goals, or SDGs, on the other.
it's the ultimate pressure test, isn't it?
It is. Moreno's central argument is that given China's unprecedented scale and speed of urbanization, and, well, the severe pollution that came with it, the core purpose of the smart city strategy had to shift.
It's no longer just about being efficient for efficiency's sake.
Exactly. It's now about engineering an urban environment that is inherently resilient, that is fundamentally environmentally friendly. They're trying to build the cities of the future, sure, but also to correct the environmental costs of the past.
Okay, let's unpack this. Starting with the tangible ways smart city tech reduces environmental impact, as Moreno details it. We can probably look at this through three core pillars.
Yeah.
The first one involves the buildings themselves, green building technologies.
Right, and this is where sustainability isn't an afterthought. It's baked right into the blueprints from day one.
So we're talking about technologies that focus intensely on energy efficiency.
Water conservation, and crucially, mandating the use of sustainable or locally sourced materials wherever they can.
And when you think about the sheer volume of new construction, the scale is just staggering. Mandating these technologies is really the only way to make a real dent.
It is. We're talking about implementing widespread photovoltaic solar panels.
Sure.
Sophisticated, energy-efficient HVAC systems that minimize power draw, and smart lighting that adjusts based on real-time occupancy and even ambient light.
So the goal here is direct and measurable.
Yes, a measurable reduction in the urban carbon footprint and a significant contribution to better air quality. Moreno is pretty clear that without these foundational mandates in the buildings, everything else is just mitigation.
Just putting a bandage on the problem.
Exactly.
Okay, so if we've engineered the buildings to be efficient, the next logical hurdle is moving people and goods without, choking the city.
Which brings us to Pillar 2, Intelligent Transportation Systems, or ITS.
And congestion is a universal city killer. It kills productivity, air quality, everything.
Absolutely.
Yeah.
And ITS moves beyond just managing traffic. It leverages a constant stream of data from traffic sensors and real-time analytics to create a closed-loop system.
So the smart traffic lights aren't on fixed timers.
No, not at all. They are dynamically adjusting traffic flow based on predicted demand and current road speed. It's proactive.
And the key outcome of that is a huge reduction in congestion, which translates directly to fewer vehicle emissions.
Yes, and better fuel economy for everyone still driving combustion vehicles.
Right.
But Moreno emphasizes that ITS is only one part of this much broader, much more aggressive strategy.
Right, because optimizing traffic is one thing, but changing the vehicles is another.
Precisely. They are aggressively promoting electric vehicles, EVs, by establishing widespread and convenient charging infrastructure. The goal is a fundamental shift away from fossil fuels.
But the biggest piece of that strategy might be the high-speed rail networks.
Oh, without a doubt. That high-speed rail element is huge when you look at carbon reduction. It's a nationwide structural fix, not just a city-level technology. It decreases the overall carbon footprint by shifting millions of people away from short-haul flights or long car trips.
Okay, so that leads us to the third pillar, which is just as important, advanced waste management.
Right, because a sustainable city has to deal with its own output intelligently.
Not just sweep it under the rug.
Exactly. In these models, advanced sorting and recycling technologies are implemented to intercept as much waste as possible before it ever sees a landfill. This is where we really start talking about the circular economy principle.
Moving away from take, make, dispose.
And the smart component here is clever. It turns the city's waste infrastructure into a data input system.
So the trash cans are talking to the system.
In a way, yes. The bins are equipped with sensors that monitor levels. This lets city services optimize collection routes based on actual need, which cuts down the miles traveled by the trucks.
Which in turn reduces fuel and emissions from the collection fleet itself.
That's right. The garbage truck isn't just emptying bins. It's acting like a mobile environmental surveyor, constantly feeding data back to refine the system.
That focus on data-driven efficiency brings us perfectly to the management of fundamental resources like water and energy. Because you can have the best roads in the world, but if you run out of water...
You have a catastrophic failure. Indeed, water management systems are paramount, especially in regions facing water scarcity and pollution. The tech response here involves smart water meters, sophisticated leak detection systems.
And this is where Moreno brings up something I found fascinating. The integration of rainwater harvesting and dedicated gray water recycling systems. Now, for anyone listening, what exactly is gray water?
It's a fundamental shift because it doubles the utility of water. Gray water is the wastewater from domestic activity, so from washing clothes, bathing, washing dishes. Crucially, it's less contaminated than black water, which is toilet waste.
So you can reuse it.
Exactly. By recycling this gray water, it can be reused for non-potable purposes like irrigating green spaces, industrial cooling, or flushing toilets.
Which immediately reduces the demand on fresh water supplies. That's a huge factor for resilience, isn't it?
A critical one. It makes the city more self-sufficient, tying directly back to that circular economy idea. It's about closing resource loops.
Okay, so let's move to the energy side. We have smart energy grids. The idea is efficient, reliable electricity distribution. But how do you integrate intermittent sources like solar and wind on a massive scale without the grid, becoming unstable?
He does address that, and that's the real technical challenge that the smart part has to solve. The key is their ability to seamlessly integrate those renewable sources. It requires advanced predictive software to anticipate supply fluctuations.
So the grid has to smooth out those peaks and troughs from wind and solar.
Exactly. And this is where the smart integration facilitates what Moreno calls demand response strategies.
Which means the system doesn't just manage supply.
It manages demand. The system can incentivize consumers, businesses, or homes to adjust their energy usage based on real-time price signals. So maybe you run your dishwasher at 2 a.m. when demand is low.
So it's an active partnership between the provider and the consumer to
Right.
maintain stability.
That's the perfect way to put it. It reduces peak consumption and makes those renewable sources so much more viable.
And rounding out the physical environment, Moreno highlights urban green spaces. These aren't just an afterthought for beautification, are they?
Not at all. They are aggressively prioritized in planning. We're talking parks, green roofs, urban forests, all strategically placed.
And beyond just being nice places to walk, what's their crucial environmental utility?
Their ecological benefits are profound. They significantly reduce the urban heat island effect, that's the elevated temperature in cities. They improve air quality by filtering pollutants, and they promote biodiversity right in the urban core. It's a technological solution that uses nature's own engineering.
So what does all this mean when we look at the bigger global picture? This is where the local action meets the global blueprint, specifically the UN 2030 Agenda.
This transition is vital. The UN 2030 Agenda is the global roadmap built around the 17 Sustainable Development Goals, or SDGs. These goals are all about balancing economic growth, social inclusion, and environmental protection.
And Moreno positions the Chinese smart city model as a highly pertinent case study in how you might actually operationalize these huge abstract global goals.
It's providing practical evidence for the theory. The methodology is clear. Sustainable practices are mandated, and advanced technologies are deployed to ensure it happens. This framework inherently reduces environmental impact, which is the definition of achieving the environmental SDGs.
Okay, let's connect the dots then. If we look at intelligent transportation and high-speed rail, which SDGs are those directly hitting?
Those map directly onto SDG 9, industry, innovation, and infrastructure, and especially SDG 11, sustainable cities and communities.
And the smart energy grids and demand response strategies.
That's a clear pathway to achieving SDG 7, affordable and clean energy. The grid's intelligence is specifically designed to manage the complexity of integrating renewables, making clean energy reliable and accessible on a massive scale.
You can see how they're not solving these problems in isolation.
Not at all. You don't solve clean water, which is SDG 6, separately from building sustainable infrastructure, which is SDG 9. The solutions are engineered to be multi-targeted.
And the green spaces, that would be SDG 11 for making cities greener.
But also SDG 13, climate action. because they are actively mitigating local climate effects, like the urban heat island. The whole model is designed to deliver on multiple priorities at once.
That's truly comprehensive. So, to summarize our deep dive into Moreno's Chapter 14, the approach to sustainability is multi-layered. From reducing the carbon footprint with EVs and high-speed rail,
To building water resilience with things like gray water recycling and increasing grid stability through demand response.
I think the biggest takeaway for you, for anyone trying to understand the system, is that its success isn't just about the whiz-bang tech.
Absolutely. It lies in integrating that technology with core, long-term urban planning principles.
Yeah.
The idea that sustainability and efficiency must be the default setting.
It's about building self-regulating, resource-efficient systems from the ground up.
And that leads us to the final provocative thought Moreno's analysis leaves us with, the integration of circular economy principles, especially in water and waste. It goes beyond just basic efficiency.
What's the end goal, then?
It suggests a goal for urban environments to become fundamentally self-sustaining in their resource loops. This holistic, self-regulating mechanism that is the real next frontier in urban design. It's aiming for a city that, by its very own design, strives for true independence from external resource depletion.
A fascinating and frankly necessary vision for the future of how we live in cities. Thank you for joining us for this deep dive.